Hello everyone, welcome to Mind Maps. In this video lecture, we are going to learn how to find out a term symbol. Okay, so let's start. So this is the basic cheat sheet that you need to follow. ठीक है, इस cheat sheet से आपको कभी भी कुछ भी निकालना हो, किसी भी element का term symbol निकालना हो, you can find it from this formula, right? So what is term symbol? Okay, this is 2s plus 1 L J. So what are these terms? You see 2s plus 1 in the superscript, okay, on the left hand side. Left hand side पे जो 2s plus 1 है, ये है क्या? Okay, this is known as R. इसको R बोलते हैं. What is R? R is spin multiplicity. Okay, spin multiplicity. Right? And what is S? How can you find S? S is number of unpaired electrons divided by 2. Okay, so when you have the number of unpaired electrons that are 2, 2 by 2 means 1. Similarly, we have other terms here. L is known as the orbital angular momentum. Okay, so we have these notations for these values. When you get L is equal to 0, it's S, 1, 2, 3, 4 and PDF respectively. This is known as the orbital angular momentum. And finally we have J. Okay, what is J? J क्या है? Total angular momentum. इसकी values कैसे होती है? L minus S से लेके L plus S तक. Okay, अब अगर ये more than half या half है, तो हम जो वैल्यू कंसिडर करते हैं वो L प्लस एस है, और अगर लेस देन हाफ है तो हम क्या कंसिडर करते हैं? L माइनस एस. ओके, so this is the limit should be less than half, right? अब ये सब चीजें हम समझेंगे थ्रू एन एग्जांपल. So let's find the term symbol for carbon. Okay, carbon. What is the atomic number for carbon? It is Z is equal to 6. Now we should consider the final orbital. Okay, the valence orbital. What is that? The valence shell is P, right? Okay, valence shell is N is equal to 2, and that's P orbitals, S and P. So S is the inner orbital, 1 is 2, it is completely filled, so it is shielded. We don't consider that, we consider only the outermost electrons that are in P. Okay, so in P we have 2 electrons, 1 and 2, as you can see on the screen. And the notations for these are -1, 0 and 1. Okay, so how do we find L? How do we find L? Think about it. So what do we do is we multiply the -1 with 1. Okay, -1 into 1 plus 0 into 1. Okay, I hope you know why we use this -1, 0 and 1. Okay, if not, then you should first find out what these are. Okay, so basic structure of atom, quantum numbers. If you go through those videos, you will find what these are. Okay, then we have the second electron, 0 into -1. So we multiply these numbers and we get 1. Now when we have 1, what does it mean? Just go back to the previous slide and see. Okay, the value of L that we found was 1. Okay, so for 1, what do we use? For 1 we use P. Okay, so what is the value of L here? It's P. Okay, so this is done. Now second we find the value of the superscript. Okay, what was that? Spin multiplicity. How do we find spin multiplicity? That's R. Okay, first we need S for that, right? R is equal to 2S plus 1, but for that we need to find S. So how do we find S? S is equal to N by 2. Now see the number of unpaired electrons. Okay, they are 1 and 2. So we have 2 by 2 equals 1. Okay. Now put the value of S in this equation. R is equal to 2S plus 1. What do we get? R is equal to 2 into 1 plus 1. That is equal to 3. We have the value of R. Okay, that is 3. We'll go back to the previous slide and we'll find the value of 2S plus 1, right? From the same cheat sheet. Okay. So what is R? R is spin multiplicity, and the value that we found was 3. So what is left? The value of j is left, right? So let us find the value of j. Okay, the value of L that we found was 1, the value of S that we found was 1. So what was the value of J? J was from L plus 1 to L plus S to L minus S, right? So first we'll find L plus S. What is L plus S? 1 plus 1 is 2, okay? And L minus S is 1 minus 1 equals 0. Now, as you can see, the number of unpaired electrons, okay? The number of electrons in the p orbitals that can be contained in that is 6, okay, but we have only 2. What is that? It's less than half, right? So when it's less than half, so what do you consider? Do you consider L plus S or L minus S? See, the values of J will be between L plus S and L minus S. The intermediate values will also be there, but we need to consider the highest value and the lowest value. So we consider L plus S and L minus S. So in this case, we have a less than half filled, okay, less than half filled situation, only 2 electrons. So what will be the value of J? Okay, 1 minus 1 equals 0. So what is the term symbol for this? What will be the term symbol? It will be 3p and 0. Okay, this is 0. This is not a smiley. This is for you. That means you have found the right answer. So 3p, 0. Right? I hope you understand how you find the term symbol for a particular element. And for practice, you can find these. Right? So you need to find the term symbol for oxygen, nickel in plus 2 state. What will you do in plus 2 state? You will remove 2 electrons from the ground state, right? From the d orbital or s orbital, right? S is the outermost 4s. You remove 2 electrons from that, and what will be left in d afterwards? So you have nitrogen in ground state, vanadium, scandium, okay, chromium in plus 3, cobalt in plus 2. So how will you find the term symbol? It is 2s plus 1 L J. What are the hints? Okay, first you need to find Z. Okay, what is Z? Atomic number or the effective atomic number, right? You need to fill the electrons in the shells. Then you need to find the number of N. N is not the principal quantum number here, right? What is N? N is the number of unpaired electrons, right? And then you do the cross multiplication and addition. You find the value of L, right? L, and then you find the value of S, and then finally you find the value of J. Okay, so what happens in S? S will have just one term that needs to be multiplied. Similarly for D, like I'll just go back and show you. See, for even if you don't know or you're in a hurry, you forgot. So for P, you have these values from -1, 0 to 1. For D, what will you do? You'll do the same thing. It will be -2, -1, 0, 1, and 2. Okay, so that's a quick shortcut how you need to remember everything, right? So I hope you enjoyed this lecture. Thank you for watching.